you comes out, what's going to happen? Let's say. So that's why I say that you have to know the structure. Okay, cysteine. What gonna be cysteine looks like? You know it already. This is the key. This free radical, we're gonna attack it here. What's gonna happen? This is cysteine, is that right? Then, very unfortunate, it becomes an adenine. And release what? Hydrogen sulfide. We don't like that. That really smells really bad. Alanine, do you think alanine is an essential amino acid? No, probably. What this means? Essential amino acids is gone, become a non-essential amino acids. The nutrition value is dropped like this. Is that right? If you want to say, like down the hill, like. That's another thing. It's happened for the lipids. From the free radical, we also will be damaged the amino acids in the protein, in the protein products.
But cysteine is not essential.
But cysteine is. Is that right?
No.
No, both of them are not?
No.
Okay. I think they are conditional. One of them are conditional.
Oh, okay.
Is that right? One of them are conditional. Or what happened is it will make the stable is not stable.
Okay.
Is that right? The double bonds will come. Yeah, I think our textbook make it clear is that the double bonds will be gone. And my point is here that the conditional essential amino acids they could be loose. They lose the nutrition function a little bit. So here, okay, last thing. We haven't mentioned last one. We haven't mentioned this here, so I just briefly. Do you remember when you buy a milk powder, do you see all those milk powder, do you see they all is in a bottle which is avoid light? They never in a transparent glass. Why? There is the photooxidation will be there. The amino acid, the lysine also will be reacted with the photo, will be reacted to lose the lysine. So that's why they always using is a sealed bottle which is avoid to the light. It's not light transparency. That's one of the reasons for that. Okay, so all these reactions so far, you should know, if we do the conclusion, the amino acids in the food products, during the processing, they're gonna missing. If they have a cross link, if they oxidize, if they become a carbonyl or become a L amino acid, become a D amino acids. They will become, which is although they absorbed it, but they are not biologically available. And sometimes, if they are oxidized, it's not very further. It's only a first step. They could become back in a different situation. If it's acid in alkaline environments, in the acid environment, back and forth, and vice versa, they could come back. But when they oxidize to the further steps, there's no way to go back. They'll lose the biology availability of the nutrition value for that. So people trying to solve the problem is the heating condition and the concentration of the alkaline is important. Now I also want to mention here, the last thing I want to mention, we talk about racemization. And we are talking about is amino acids. But there is a research has been showing when you use amino acid, the reaction rate is actually not very strong. But when you use protein, the amino acid is in the protein, it's going to be very strong, the reaction. Why? Because the protein have an intramolecular force. The intramolecular force will dramatically lower down the energy required for the racemization. So that's very interesting, they see it. Amino acid, free amino acid is actually not very sensitive for the reaction, but once it's composed in a protein, it will be very easy to from D, L to D. which means lose biological availability. Now, of course, the second factor for causing racemization is the concentration of the hydroxy bonds, which means the concentration of the alkali concentration. The higher, of course, is more severe going to happen. Okay, so here is all I have today. We gave you the overview of these biochemical reactions of the amino acids.